When dealing with an overcrowded wire opening in an existing wall, an old workbox can be a practical solution to expand the space and accommodate the wiring for two three-way switches. This involves a series of steps to ensure a safe and code-compliant installation. Firstly, gather the necessary materials, which include an old work electrical box, specifically a 2-gang box, a drywall or plaster saw for cutting the opening, a screwdriver for securing the box and switches, and wire strippers for preparing the wires. Next, prepare the opening in the wall. Mark the location where the old workbox will be installed, ensuring it covers the existing opening. Using the drywall or plaster saw, carefully cut out the opening, taking care not to damage any existing wires. It's crucial to proceed cautiously to avoid any electrical hazards or damage to the surrounding wall. With the opening prepared, insert the old workbox into the wall. Position the box from the front of the wall and ensure it fits snugly into the opening. Secure the box to the wall using the mounting screws provided with the old workbox. These screws typically tighten against the back of the wall, clamping the box in place. Now, move the existing wires into the new, larger box. Carefully disconnect the wires from the existing electrical box, making sure to de-energize the circuit before doing so. Pull the wires into the larger space provided by the old workbox, leaving enough slack to work with when connecting the switches. Adequate slack allows for easier manipulation and connection of the wires. Before connecting the switches, prepare the wires by stripping the ends. Use wire strippers to remove approximately 1/2 inch of insulation from the ends of each wire. Twist the bare wires of each circuit together to ensure a secure electrical connection. Typically, you'll have one bundle for each switch. With the wires prepared, it's time to connect the three-way switches. Position one three-way switch in each gang of the old workbox. Connect the wires as follows. Connect the black wires, which are typically the hot wires, to the common terminals of both switches. The common terminal is usually marked with a darker screw color, often black or brass. Connect the red wires, which are traveler wires, to the other terminals on one switch. Connect the white wires, also traveler wires, to the other terminals on the other switch. It's important to maintain consistency in the wiring to ensure the three-way switches function correctly. After connecting the wires, secure the switches in place. Tighten the mounting screws to secure the switches in the old workbox. These screws hold the switches firmly against the box, preventing them from moving or becoming loose. Finally, install the faceplates to cover the screws and provide a finished look. The faceplates protect the wiring and add a professional touch to the installation. It's important to note that using this method will expand the wall opening by the width of a single gang, approximately 1.5 inches. Additionally, always follow local electrical codes and consult a qualified electrician for any electrical work. Electrical codes vary by location and are designed to ensure safety and prevent hazards. A qualified electrician can provide guidance and ensure that the installation is performed correctly and safely. When working with electrical wiring, safety should always be the top priority. Before starting any electrical work, de-energize the circuit by turning off the corresponding breaker at the electrical panel. Use a voltage tester to verify that the circuit is de-energized before touching any wires. Wear appropriate personal protective equipment, such as safety glasses and insulated gloves, to protect yourself from electrical hazards. If you are not comfortable working with electrical wiring, it is always best to consult a qualified electrician. Electrical work can be dangerous, and it is important to have the necessary knowledge and experience to perform it safely. Remember to double-check all connections and wiring to ensure they are secure and properly insulated. Loose connections can cause electrical problems, such as flickering lights or power outages. Properly insulated wires prevent short circuits and electrical shocks. Regularly inspect your electrical system to identify any potential problems, such as frayed wires or damaged outlets. Addressing these issues promptly can prevent more serious electrical problems and ensure the safety of your home. Consider using arc fault circuit interrupters of size in your electrical panel to provide additional protection against electrical fires. A size detect arc faults, which are a common cause of electrical fires, and trip the circuit breaker to prevent a fire from starting. Ground fault circuit interrupters, GFCIs, are also important safety devices, especially in areas where water is present, such as bathrooms and kitchens. GFCIs detect ground faults which can cause electrical shocks and trip the circuit breaker to prevent injury. When choosing electrical components, such as switches and outlets, select products that are UL listed or certified by another reputable testing laboratory. UL listing indicates that the product has been tested and meets safety standards. Following these safety precautions and best practices will help ensure a safe and reliable electrical system in your home. Electrical safety is an ongoing process, and it is important to stay informed and take proactive steps to protect yourself and your family from electrical hazards. If you have any questions or concerns about electrical safety, consult a qualified electrician. They can provide expert advice and assistance to ensure that your electrical system is safe and up to code. The National Electrical Code (NEC) provides comprehensive guidelines for electrical installations. Familiarizing yourself with the NEC can help you understand electrical safety requirements and ensure that your electrical work is compliant. Some key aspects of electrical wiring include wire gauge, circuit breaker size, and grounding. Wire gauge refers to the thickness of the wire, which determines its current carrying capacity. Using the correct wire gauge is essential to prevent overheating and fire hazards. Circuit breaker size refers to the amount of current that a circuit can safely handle. Using the correct circuit breaker size is important to protect the wiring and prevent overloads. Grounding provides a path for electrical current to flow safely to the ground in the event of a fault. Proper grounding is essential to prevent electrical shocks. When working with electrical wiring, it is important to use the correct tools and materials. Use insulated tools to protect yourself from electrical shocks. Use wire connectors to make secure and reliable connections. Use electrical tape to insulate wires and prevent short circuits. Always turn off the power before working on any electrical circuit. Double check that the power is off by using a voltage tester. Never work on electrical circuits while standing in water or on a wet surface. Water conducts electricity and can increase the risk of electrical shock. Be aware of your surroundings and avoid touching any metal objects while working on electrical circuits. Metal objects can conduct electricity and increase the risk of electrical shock. If you are unsure about any aspect of electrical wiring, consult a qualified electrician. It is always better to be safe than sorry when it comes to electricity. In addition to the NEC, there may be local electrical codes that you need to follow. Check with your local building department to find out what the local electrical codes are. Always follow the most current version of the NEC and local electrical codes. Electrical codes are constantly updated to reflect the latest safety standards and best practices. When making electrical connections, be sure to tighten the screws securely. Loose connections can cause electrical problems and increase the risk of fire. Use the correct type of wire connector for the type of wire you are connecting. There are different types of wire connectors for different types of wires, such as copper and aluminum. When installing electrical boxes, be sure to secure them properly to the wall or ceiling. Loose electrical boxes can be a safety hazard. Use the correct type of fasteners for the type of wall or ceiling you are installing the electrical box in. When running electrical wires, be sure to protect them from damage. Run wires through conduit or other protective materials to prevent them from being damaged by nails, screws, or other objects. Avoid running wires in areas where they could be exposed to water or moisture. Water can damage electrical wires and increase the risk of electrical shock. Regularly inspect your electrical system for any signs of damage or wear. Look for frayed wires, cracked outlets, or loose connections. If you find any problems, have them repaired by a qualified electrician. Consider having your electrical system inspected by a qualified electrician every few years. A qualified electrician can identify potential problems and ensure that your electrical system is safe and up to code. Remember that electricity is a powerful force and should be treated with respect. By following these safety precautions and best practices, you can help ensure a safe and reliable electrical system in your home. Remember, Always consult a qualified electrician for any electrical work if you are not comfortable performing the work yourself. Safety is paramount when dealing with electricity. Consider the amperage of the circuit you're working on. Branch circuits are commonly 15 amps or 20 amps. Knowing the amperage helps you select the correct wire gauge and circuit breaker size. For example, a 15 amp circuit typically uses 14 gauge wire, while a 20 amp circuit typically uses 12 gauge wire. Refer to NEC Table 310.13b16 for ampacity ratings of conductors. This table provides the allowable ampacities of insulated conductors rated up to 2000 volts, based on their insulation type and temperature rating. When connecting wires, use wire connectors that are appropriate for the wire size and type. For example, use twist-on wire connectors, commonly known as wire nuts, for connecting solid or stranded copper wires. For larger wire sizes or connections involving aluminum conductors, use compression connectors or other connectors specifically designed for those applications. When installing switches and outlets, ensure they are properly rated for the voltage and current of the circuit. Most residential circuits operate at 120 volts. Switches and outlets should be rated for at least 15 amps. Use tamper-resistant receptacles, TRRs, especially in homes with children. TRR have internal shutters that prevent objects from being inserted into the slots unless both prongs of a plug are inserted simultaneously. When running cables through walls or ceilings, protect them from physical damage by using cable staples or cable ties to secure them to framing members. Avoid over-tightening the staples or ties, as this can damage the cable insulation. When installing recessed lighting fixtures, ensure they are IC rated, which means they are suitable for direct contact with insulation. Non-IC rated fixtures can overheat and pose a fire hazard if they are covered with insulation. When working on electrical projects, it is essential to have a well-equipped toolkit. Some essential tools include wire strippers, pliers, screwdrivers, a voltage tester, a multimeter, and a fish tape. Use a voltage tester to verify that a circuit is energized before working on it. A multimeter can be used to measure voltage, current, and resistance in a circuit. A fish tape is used to pull wires through conduit or walls. When working with electrical boxes, be sure to select the correct size and type for the application. Electrical boxes are available in various sizes and materials, such as metal and plastic. Choose a box that is large enough to accommodate the wires and devices being installed. Use a level to ensure that electrical boxes and devices are installed plumb and square. This will improve the appearance of the installation and ensure that devices function properly. When working on electrical projects, it is important to stay organized and keep your work area clean. This will help prevent accidents and make it easier to find the tools and materials you need. Always dispose of electrical waste properly. Recycle old wires, cables, and electronic devices whenever possible. Do not dispose of electrical waste in the trash, as it can be harmful to the environment. When working with electrical wiring, be aware of the potential hazards of electromagnetic fields, EMFs. Minimize your exposure to EMF by maintaining a safe distance from electrical sources and using shielding techniques when necessary. Consider hiring a qualified electrician to perform a home electrical inspection. An electrical inspection can identify potential safety hazards and ensure that your electrical system is up to code.